look at the notes here. It says graph the following in 4 different colors. So here's what it should look like. I have a different graph on mine, but it should still look the same. So something that we notice is that it's linear, goes through the origin, and they're positive. Changing the slope affects the steepness of the line. So make sure you include that word steepness. Slope changes the steepness. You don't have to write it exactly like that. You just need that word steep or less steep. And if we list out most steep to least steep, that would be D, A, B, C. So look at these numbers. 4, 2, 1, half. So the bigger the number, that means that it's going to be a steeper line. The closer the number gets to 0, think about what a 0 slope is. 0 slope is a horizontal line. The closer it gets to 0 slope, the closer it gets to a horizontal line. So we're ignoring positives and negatives. We're just looking at the M, which is our slope. Part 5, when we graphed those, we had a positive 3x and a negative 3x. So it was the green and the pink for mine. See how there's a reflection? So it's a mirror image, which in math we're going to call that a reflection. And then same thing for x and negative x. So positive is going to rise from left to right, and negative falls from left to right. If they have the same exact number, they have the same steepness, it's just a reflection. So these two have the same steepness because they both have 3, but one's a positive and one's a negative. Okay, let's look at the next one. Number 7, when you graph these lines, which remember I have a different graph on there, so it's going to look a little different. But if we look at these lines, see how they are parallel to each other? They never intersect. They have the same slope, but the Y-intercept is different. Make sure you're adding these things to your paper. So parallel, same slope, Y-intercept is different. See how all the slopes are 2? So that means same steepness, which means parallel. Same slope means parallel. Number 9, how does changing the Y-intercept affect the graph? The lines are translated up and down on the y-axis according to the Y-intercept. So remember learning about translations? Translation is when you move something. You slide it on the grid. So if we have this, then it is slid down, but the steepness stays the same. It's just sliding up and down that y-axis or up. But the steepness is staying the same. Okay, let's look at the graphs that you had for homework last night. Those 6 graphs. If you already turned it in, go ahead and get it back out. number 1, 2, and 6 are all written in y equals mx plus b form. So in order to graph these, you will graph your y-intercept first and then do your slope, just like we did the other one. So on number 1, we would graph our y-intercept, which is 1, and then do our slope. Rise 3, run 4. So you're going to count 1, 2, 3 over 1, 2, 3, 4. And to get to the other side of the y-axis, you go the opposite. Instead of going up 3, right 4, I'm going to go down 3 and left 4. Make sure to use a ruler to connect this. I'm going to count off points if you don't make a straight line. You can use anything as a ruler, a folder, your composition book. You can use anything as a straight edge. So make sure you make this a straight line. Whenever we look at 3, 4, and 6, they're all written in ax plus by equals c. So the other day we did finding the x and y intercepts, which is this. So to find an x-intercept from an equation, replace y with 0 and solve for x. To find your y-intercept, you're going to use the equation to replace x with 0 and solve for y. So that's where we covered them up and solved for the variable that we wanted the intercept for. So if we do this one, well, I'm going to do, I guess number 6. So if I want to find my x-intercept, then I'm covering up y because that becomes 0. So I look and see, what do I have left whenever I cover that up? X equals -4. So my x-intercept is at -4. So it's -4, 0. Make sure to write it as a coordinate. Don't just write x equals a number. Write it as a coordinate. So we go to the x-axis and we plot that -4. And then when we do our y-intercept, we cover up our x and write down what we have left, -2y equals -4, and solve for y. So I would need to divide by -2. So y equals -4 divided by -2. Positive 2. And so our coordinate would be 0, 2. Because our x value is 0, our y value is 2. So go to your y-axis and plot that point. And you're going to turn that in. Let me pass out the foldable that we are going to use to sum. So this is a foldable for today. So this is all about transformation. So whenever we glue it in, we're going to title our page Linear Transformations. So up at the top, I do want us to write what our linear parent function is. The linear parent function is the most basic linear function. So it is going to be the one that goes through the origin. It has a positive slope, and the slope is 1. So that is f of x equals x. It's the most basic linear function. So let's write our characteristics. So it's positive slope goes through origin and m equals 1. So every linear function comes from this linear parent function. It can also be written as just y equals x, okay? You can write it as f of x equals x or y equals x. You'll see them both ways. So every function comes from this linear parent function. You do some kind of transformation on it. So the transformations that we learned on our notes today was the change in the steepness. So that's going to be our first change we're going to talk about. So f of x equals x transforms to g of x or h of x or p of x or whatever. They can change this function name to anything. It changes the slope. So we're going to call this a times f of x. So it's taking what the linear function is, just y equals x, and multiplying that function times a value a. A can be anything. It could be 10, it could be 5. So what this is, this changes the steepness. Steepness is changed by a factor of, let's call this a. So slope is basically changed. If you change the steepness, you're changing the slope. So let's say we have g of x equals 3 times f of x. This is just an example. So that's what we're going to do with our graph. So the change here is changed by a factor of 3, sorry. Is it going to be steeper or less steep if we have a 3? Yeah, it's going to be steeper because remember this? This was the steepest graph. And then it went down from there. So the bigger the number, the steeper it is. So put steeper by a factor of 3. So I'm going to graph it here. This function right here is just f of x equals x. And then this function is going to be 3 times whatever f of x is. So that's just 3x. So let's graph it. It has the same y-intercept. So our y-intercept is 0. our slope is 3. So that means I'm going to go up 3, right 1. These graphs are tiny. Up 3, right 1. And then we're going to go down 1, 2, 3, left 1. Down 3, left 1. That's all we can do. Use your ruler to make a straight line.
Wait, how did you do it?
So I plotted my 0, 0, because that's my y-intercept. And then I did my slope, 3 over 1. So rise, go up 3, right 1. Okay, the next transformation that we did, let's look back at the notes. The transformation here was reflecting it by changing the sign. So we're going to summarize that here. So we're going to say f of x equals x, g of x equals negative f of x. So whenever you change the sign, it's going to be a reflection. So then our example is just going to be g of x equals negative f of x. That's it. So we're going to graph it here. So this is f of x equals x. This would be g of x equals negative x. So to graph this, we start at our origin, then we go down 1, right 1, because our slope is negative 1 over 1. So down 1, right 1. Okay, so let's draw your line. So the only thing that changes whenever you do a negative in front of your slope is it flips it. It makes it a reflection across the axis. Okay, the last type of transformation that we did on our notes was changing the y-intercept. Keeping the same slope, changing the y-intercept. So this is going to be g of x equals whatever f of x is plus some value called k. And you can also do minus k. If I do plus k, the line's going to move up. If I do minus k, the line's going to be down. So let's write that. Translate up if it's a positive k. Translate down if it's a negative k. So our example is going to be g of x is found by doing whatever f of x is minus 5. So what's going to happen to the line? Down 5. So here's our original f of x equals x. So this one is going to be g of x equals whatever f of x is, which is just x minus 5. So that means I'm going to go down 1, 2, 3, 4, 5. But what's going to stay the same? What's the steepness on this one? And on this one? Yeah, they're both 1. So what's the only thing that changed? The y-intercept. So we're going to go up 1 over 1. Up 1 over 1. Up 1, right 1. Down 1, left 1. And with transformations, you can have a combination of any of these together. So let's see what we'll go to the next page to do what are the transformations. So I just want you to write what the transformation is. Was it translate, reflection, what was the other one? Steepness, the slope. And it can be a combination of them. So I'm going to pause it and let you work with your table groups.